Okay, so 570 is where we start. We'll get to 13.4 in a minute. We'll go 570 answers first. So what was the word of the day from yesterday? What type of things were these? Geometric is true. What did geometric mean? Kept multiplying the same number over and over and over again, and that number was called the ratio. So on 1 to 6, all they ask you for is to figure out the ratio, to figure out what were you multiplying by. To do that, if you're trying to figure out what is being multiplied, you're going to do a little bit of algebra concept and divide, because you always do the opposite. If you have to go and divide, you can divide any term by the one to its left is correct. So that's what we're after here, 1 to 6. Did you get one? 2. It is 2. Do you have 2?
-3.
That's close. Do you have something close to that? Do you have something close to that? Negative a third. Make sure we divide by in the right order, because dividing's picky. So negative a third is true. 3?
-1.
Negative 1 is true. 4? No go. 4?
I'm almost there. 1 more second.
We'll give him a second.
Oh, 4.
4?
Oh.
That's
That should be. It looks like it's. My guess is getting divided by like 0.01.
That's close.
0.1.
0.1 is true. 5 is an XE kind of fraction.
I thought I was doing 7.
1 over x.
1 over x is true. 6 is another fraction with a letter in it. It is m over 2. Anybody need guidance on how to do 1 to 6? 7, we want to work through the general term. So I'll throw that up here. General term formula for geometric, what was that?
A1.
First term times
Ratio.
ratio,
K plus 1. K minus 1.
and then some letter minus 1, whatever that letter may be. So for 7, I would suggest you do that, and then if you want the 6th term or the 10th term or the 9th term or whatever term you want, once you get the formula written, you just plug in. If I want the 10th term, you plug in 10, where the
N.
n is. And that's what we're chasing here on 7, is just kind of working through that. Or if you're patient, I guess since you're only going to the 6th term, I mean, you could just keep going a couple more terms. That wouldn't be the worst thing in the world. But the quiz is not set up when we take it next week to do the 6th term. It's going to always ask you for like the 50th term or the 80th term or something that you would not have the patience to do. You'd have to work through the formulas. 7,
243.
it is 243. 8 is a fraction or decimal. No go. 8 fraction or decimal.
17 over 64.
If you had 1 and then 17 over 64,
Yeah.
I would agree. It could have also been 81 over 64, or it could have been a decimal that was 1.265625. Any of that would work for me. 9's over 1,000. No go. Did you get to 9? Back to the front. Or, yeah, 9. No go. No go.
So I have a negative.
Okay.
1,002.
It is 1250. 10 is like in the hundreds.
162.
It is 162. 11 we could do, you didn't need fancy math. The process to do this would involve roots, but there would be a guess check way if they're kind to you. They're kind to you here, so you can kind of guess check your way into figuring out the missing number. It is 12. 12 we could also go kind of like a guess check system. Either of you pair, can you guess check your way into that one on 12, or you want me to skip ahead to the next guy?
No, also just 12.
No, because we have to get 2 jammed in there. 4 to something.
Oh,
to something
2.
to
I thought we were
30.
only getting 1.
Yeah. Skip ahead a guy.
8 and 16.
8 and 16 would be the missing numbers. So what you would write there for an answer is a list that includes the beginning and end that you knew. You'd go 4, 8, 16, 32. Go ahead, write the whole list. I skipped 13, 14 because I didn't care. And then 15 we went into sums. So by the time the test arrives, you need to know the sum formula. What kind of a math thing was the sum formula? It is a fraction. The bottom was smaller.
1 minus r.
It was 1 minus the ratio. The top was bigger.
A1 minus A1 Rn.
Correct. And then if you're using your calculator, you need to also type in what you can't see. Parentheses for whole top, whole bottom. But we're using that formula for like the next, I don't know, 10 in a row-ish, something like that. 15, 762 is true. 16 won't be a whole number, it's going to be a fraction or decimal kind of number. It is 10 and a half. 17 is another fraction or decimal kind of thing. 547 over 18 is fine. 30.38 with a line on the 8 would be fine. 30 and 7/18 would be fine. It just depends on what you want to do with that. 18 is a decimal or fraction. Okay, that one went off. 18 you have a shot at? No go. Anybody a shot at 18, fraction or decimal? Yeah, if you go decimal, it's 6.6666. That's a little bit of a troubling number. If you wanted to go fraction, it's 33,333 on top of 5,000. Either of those could work for me. 19 is going to be a formula that just has x's in it. It's going to look like this, but you're going to just kind of only replace the stuff that you can't.
1 minus x to the 8 on top of 1 minus x.
Yep. And that's what the book did. I have an answer that's, I think, better than the books. We can come back to that. But the book went with 1 minus x to the 8 over 1 minus x. Does anybody have any kind of suggested way how we can improve upon the book's answer using some algebra skills from around chapter 5 that we did?
You'd have one pair that'd be like x plus, or like 1 minus x to the 4. 1 plus x to the 4.
Yeah, we could take the top and turn it into those.
And then like do it again.
And then do it again. So would this one go again?
No.
No, but this we could go a minus squared, but then a plus that's squared. Would that one go again?
No.
No, but this one
Yeah.
could go 1 minus x, which would cancel,
That would be plus
and a
x.
1 plus x. A better answer might be that trio of factors, because we canceled and did stuff, but I don't care about that. 20 would be a lot like 19, but it doesn't factor and simplify. It's just 1 minus some stuff on top of 1 minus some other stuff. Anybody get 20 numbers plugged in to get something like that?
1 minus x to the 20 on top of 1 minus x squared.
It is 1 minus x to the 20 on top of 1 minus x squared. 21 is going to be a fraction or decimal, back to using this formula again. Anybody have that one? 63 over 32 could work. 1.96875 could work. 22 is a whole number in the 500s. It is 510. 23 is in the 20,000 size range.
21,800.
It is 21,844. 24 is going to be a fraction or decimal. 121 over 81 is a fraction that works. 1.49382716, and then I don't know where it goes from there. I don't sense a pattern to it, but would have to have one. That would be a decent decimal for that. Basically up to 12, this was running it, and then when you got to 15, this was running it. Again, big thing for test day, make sure you know the formulas. If you don't know the formulas, it's going to be trouble. Question about 570. Anything I could do to troubleshoot anything?
Could you do something to me?
17. So the ratio would be a -3. Are you okay with that? If I do any fraction divided by the one that's before it, I'd have to flip the one that was before it. I'd get some canceling. Does -3 make sense?
Yeah.
Okay. So then when I go to the formula here, I would need a -3 there. Minus minus, make a +3 there. They wanted, I think, 7 of them. And the first term we had was that 118. Is that okay?
Yeah.
And then just button push.
Okay.
More anything that went sideways on anybody from page 570,
21.
21. So 21. 21, I'm positive from experience, the ratio would be a half, because the number that goes to the power is always going to be the ratio.
Yeah.
Does that make sense?
Yeah.
So I can stick the halves in to 2 of the slots. Then we're going 1, 2, 3, 4, 5, 6. The K's run from 1 to 6. So we're finding six numbers. So this would go to 6. We don't know the first term, but we can figure out the first term if we plug in the lowest number below the sigma sign. So if you plug in the 1, anything to the 0 makes 1. So those would be 1s there.
Okay.
Are you with that?
Yeah.
I would save some button pushing. Sometimes you just need to button push the whole giant thing. But this, I would do some stuff to save some button pushing, I think. Because 1 times stuff is just that stuff, so we don't need that 1. 1 minus a half is a half. So I might just punch in that version of the problem. 1 minus, do this out, divide by a half. See where that'll go. More stuff to 570, 571, anything people had that was confusing. Again, I'll put in another stress for it. Learn the formulas. If you have the formulas, it's pretty easy to do. If you don't have the formulas, it's pretty impossible to figure out the sums. You could figure out the general term if you're math creative, like we talked about 2 days ago, but I think it's easier with the formula. Last call. All right, last lesson of your year, 13.4. We're talking about geometric series still, but they're infinite, meaning
Go forever.
go on forever, but we're still going to try to find the sum. So yesterday, you started to think about that a little bit, and it kind of like made your brain hurt, I think. To have something that goes on forever, but if you add it all up, you can do it, and it is sometimes possible to do that. So let's do one. So if I do the sum of all the numbers so far to there, it's obviously just
Infinite?
a half.
Oh.
That's all we see. Okay. If I go another number and do sum number 2,
A 4.
a half plus a fourth.
6.
An 8. 2 eighths.
3/4, because you'd have to make a common denominator if you're going to change the bottoms,
Change the top.
change the tops. So you would turn this into 4, that's a 2, 2/4 and 1/4
3/4.
is the 3/4 that somebody said. If we go sum number 3, take the 3/4 we had, add on another 1/8.
7.
It would be 7/8. If I go sum number 4, take 7/8, add on another 16.
15
It'd
over
be 15/16. Without me even writing the next number. The next bottom,
31 over 32.
next bottom will be 32, because what's the bottom keep doing? Doubling. And the top would be 31, because the tops are always
Just minus 1 from
1 less. So my next number, bottom, would be
64.
64,
63.
63. At some point, might you get up around 1 million?
Yeah.
Not exactly 1 million, but like up around there.
Close.
If the bottom were 1 million, what would the top be?
999999.
Eventually, might we get up around 1 billion?
Yeah.
Yeah, the top would be
Three more
nines.
3 more 9s. So I think you can safely come to the conclusion, this just keeps getting closer and closer and closer and closer, closer and closer and closer and closer and closer and closer to 1. Is half close to 1? Not really. 3/4 close to getting 1 whole? Maybe. You know, you got 3/4 of a cake. Did you get most of the cake? Did you get the whole cake? Not so much. 7/8, you pretty much ate the whole cake. 63 64ths of a cake, you might as well have eaten that whole cake. If you had 999,999 out of the billion, just eat the whole cake. Like, what are you doing? Like, this is absolutely getting closer and closer and closer and closer to 1. Would it ever land exactly on 1?
No.
That's an argument for another day. That's like a calculus discussion in chapter 2 about limits and whether you're there or not.
Because
But-
the numbers can go on forever.
For all basic purposes, is it 1? Yeah. A similar question I could ask would be, that wall is a certain distance away from me. If I cut that distance in half, and I cut that distance in half, and I cut that distance in half, would I ever touch the wall?
Eventually, maybe.
You could kind of argue for no, because there's always like a distance there. But at some point, that distance would become so small that you can't even
Yeah,
Move it.
like
see it or measure it or whatever. You know, if you created the tiniest thing ever, so tiny you couldn't measure it, could you cut it in half?
Probably.
Probably. But if you already can't measure it,
It's gonna be hard. That's
how
much.
would you?
Got it.
How would you know that you did? Like, it's, yeah, the things are so tiny, but those are like weird conversations maybe for another day. But what we're gonna just say is, for the purpose of this problem, it's just 1. We're just gonna say it is. We'll take it by faith. So this is the sum formula that we can use. The sum formula for this is way easier than the sum formula that I just erased. Is the bottom same or different?
Same.
Same. But the top, instead of that big crazy thing, you just need the first term. So if I'm going to do an infinite series, I just need to grab the first term, which in this case was half, and go 1 minus the ratio, which in this case was, we didn't figure it out, but ratio was a half. 1 minus a half is a half, and anything dividing itself is 1. The way we figured out it was headed to 1 was reasonable, but I think it's a lot quicker to use the formula, and just the answer's going to be a 1. Question about that? You can only find the sums on sequences that are called converging sequences. There's another category that's called diverging sequences, and you can't find their sums, which is what you probably thought about yesterday. It's infinite. I can't find the sum. It'll just get bigger forever. That's stupid. Wow, how would I even do that? Well, for this we can do it because gradually each item becomes worth less and less and less and less and less. So at a certain point, you're basically adding on something close to nothing. You know, add on a 16th, okay, that's worth something. But when you add on a 32nd, add on a 64th, eventually you add on a billionth, you get to a point where you're like, I don't even want that. That's not even worth anything. You know? So here's 4 sequences. Some of these converge, some of these diverge. I haven't explained the words yet, but I will. But does anybody have a feel for this enough to venture a guess as to 1, 2, 3, 4? Either somebody who's converging, and we would be able to find the sum, or somebody who's diverging, and therefore you cannot find the sum. You have a guess?
2.
Is which?
1.
2 is converging. And so in a minute, we will find the sum. Does somebody other than her make another?
4 diverging.
4 is diverging. We will not find the sum, we'll just say it diverges and we'll quit.
Well, you know, we're gonna go with 3 as C.
3 is a converge, we will find the sum.
And it's 4.
One, D.
4,
There's 1 all.
That's a D.
4 is a diverge, all we would do is say it diverges and we quit. Can anybody explain how you're making that
Fractions.
choice?
It's my best.
Converge, that's
They go
Less
down,
than one.
conversion go up.
Okay, if the numbers are getting smaller, that is gonna be an indication of converge. If the numbers are getting bigger, that's gonna be an indication of diverge, that's true. Fractions can be involved, but we're gonna make that a little bit more of a precision thing. Fractions for what? What's the key word behind anything geometric? It is multiplying, but then there's a vocabulary word. Powers are involved. Okay.
Ratio.
Ratio is the key word. So these somehow have something to do with the ratios. We're close on the advice that the ratios are fractions, but if the ratio, let's say this is your ratio, that is a fraction.
Over 1.
So, like, everything is a fraction. So we do, to say it's a fraction is a kind of in the right idea, but not quite exactly perfect. But let's figure out some ratios. This ratio would be 1/4. This ratio
A third.
is a third. This ratio
A fourth. Negative a fourth.
is negative a fourth. This ratio
6.
Six.
Negative 6.
is negative 6. So the ratios of this type cause the diverge. Ratios of that type cause the converge. These are fractions. That is a right idea, but like I just said, those are fractions too, because they can be put over
Is it
1.
fractions that can't be whole numbers?
Over 1, like only under 1.
That's a decent guess, but not quite right. Let's say the ratio were
It's a ratio.
5/2.
Less than one.
If the ratio were 5/2, would those numbers be going smaller or bigger? They'd be going bigger. So that would mean it would converge or diverge. That would be a diverge. So if we had a ratio of 5/2, that would still be a diverge.
Fractions that are less than 1.
There you go. So that's getting very close. So this is a fraction under 1, that made it converge. This is more than 1, that made it diverge. Is this more or less than 1?
It's less.
That's less than 1. But
So-
that didn't converge.
Absolute
More than
value
negative
of the
1,
ratio
less than 1.
is less than
Correct.
one.
We're gonna throw in a math thing that makes the sign not matter. Okay, what math thing have we done since algebra 1 together that it makes the signs kind of just gone? Absolute value. So if you do the absolute value of a ratio and it's under 1, we're gonna converge. If you do the absolute value of a ratio and you're more than 1, it's gonna diverge. So like the absolute value of this is 4. Absolute value of this is 6. Those have absolute values more than 1, which makes the size of the numbers getting bigger. Okay. This one is sort of weird because the positive is winning, then the negative beats it out. Then the positive would be winning a while, and then the negative would beat it out, and then a positive would beat it out. And it's going to bounce. Eventually, it's going to actually start bouncing between negative, negative billions, call it negative infinity, and
Positive.
positive infinity. It's going to like bounce from one extreme end of the number line to the other because the signs are taking turns. So we can't add that up. That's just bonkers. This is going positive, bigger, 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 ginormous, ginormous, bigger, bigger. There's no way you could ever add that up. That's going to diverge. But if the absolute value is less than 1, it's going to converge.
Going down.
So let's do the sum on this one. Just follow the sum formula, circle it for easy location.
1.
Top would be a 1 because first term.
There's the third.
1 minus a third because we grabbed that ratio. Let's do the math on the bottom. 1 minus a third
2/3.
is 2/3.
Over.
Leave that alone.
Okay.
And then I would envision this symbol to mean what operation? Divide. If 1 is dividing a fraction, what happens to your fraction? It just flips. So if 1 divides this, makes this flip, the grand total would be 3 halves. If you don't trust your fraction mental skills, just grab the machine, throw your parentheses in there, push some buttons, it would show up a 1.5 instead. I'm fine, whatever, decimal fraction, I don't care. Something there. This one, similar approach, top is 4, bottom, 1,
Minus.
minus,
So plus.
negative, so minus minus makes plus a fourth. And then I would try to add that. If we add those together, keeping it as a fraction. 1 1/4, let's do an improper fraction, it'll be better. 5/4. So if 4 divides 5/4, the 4 is like it's over 1, so the second one flips 16 over 5. If your mental fraction good, just do that. If your mental fraction bad, just push buttons, it's fine. 3.2 would shoot out of that one. That's it, you're over.
Oh, that's it?
That's it.
Yay.
So, what's happening up next? Homework that would be due for Monday would be page 574. We're going to go from 1 to 14. We're going to ignore their directions. And what we're going to do is say for every problem, say what the ratio is. For every problem, say if it's a converge or diverge, C or D is good enough for me. And then if you're putting a C, do the math formula to figure out the sum. So 1 to 14, that'll be the quickest, easiest homework of the chapter. Sometimes this motivates people when I say this. You could get this done in class. 14 of those, and there's 14 minutes. That could be done. So we're 574, we're 1 to 14. Ignore their directions. For every problem, put the ratio, which they didn't say that always. For every problem, identify whether it's the C or the D for converge or diverge, which they didn't always say that either. And then the ones that converge, find the sum. They did a mix of those things depending on the problem. I just want to do them all the same way. So ratio, converge or diverge, and sums when you put the C.
Can I take a picture of the board?
Sure. So for Monday, we're looking to do that homework. Seniors, if you want to get that done while you're in the building, I'll give you a bonus homework, extra credit homework for that. So for Monday, we do that. Monday, we'll look at homework answers. Tuesday, there would be a sheet due. I'm just going to give you the sheet now. The sheet covers everything we did in the chapter. So this sheet would be due Tuesday. We basically have a day to burn, so I'm going to do a second review sheet that's just like the first. We'll do that for Wednesday, so you get a double review to be like a super genius. And then Thursday would be a chapter 13 test in the final exam slot. Homework, any homework from this chapter, I think I told you this date already. Each class I made a different due date just so I'm not getting pounded with homework all the same day by everybody. For you guys, any homework is due by Tuesday next week. So Monday, the 574 is due. I'll still take that Tuesday, but Tuesday is it. This would be due Tuesday. Another sheet due Wednesday. But fixing chapter 11, old stuff like that, that would all be due by Tuesday. All the homework is due by Tuesday. Question about anything there? All right. Thank you, cameraman, for your year. For the final time, I'll tell you, let's shut it down.